This is Radiolab. I'm Lulu Miller. So Earth Day is coming up in just a couple of days, and we wanted to take a moment to truly consider the value of Earth, which is admittedly a sort of doomed and impossible task, but it's also super fascinating to watch people try. So today we've got two stories for you about people attempting to evaluate the invaluable. So join me if you will, take a sip of water. Cheers, the blue planet that gives us all life. And enjoy this episode from the archive, which we are calling Ghosts in the Green Machine.
Yeah, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
Rewind.
I'm Robert Krulwich. This is Radiolab, the podcast. And today we're going to talk about global warfare. A vast battle across the planet on a scale that is really hard to believe, involving trillions of deaths. And yet, we really need this war because without it, I wouldn't be here, you wouldn't be here, Jad wouldn't be here, and you may have noticed he isn't here, and it's not because of a war, it's because he had a baby. But before Jed went on paternity leave, we sat down with Ari Daniel Shapiro.
Okay.
And he told us this story.
Here it comes.
All right, yeah. So here we are at the Center for the Culture of Marine Phytoplankton.
This is Willie.
And I always say
Willie Wilson.
Willie Wilson is his name?
Yeah.
That's tough.
Just like his grandfather, actually.
Yeah. My dad's William Wilson. There's a long line of William Wilsons.
Your son?
My son is Angus, but he's Angus William Wilson. So
I love that guy.
Willie works at the Bigelow Laboratory for Ocean Sciences in Maine.
Okay.
And he studies these tiny plant-like creatures that live in the sea called phytoplankton.
right.
He keeps them in a fridge in these little test tubes, half full of kind of greenish water.
Let's have a look at this.
He pulled one out and showed it to me. And it doesn't really look like there's that much going on in there.
But actually, right at the bottom, you can see what looks like a
White.
sort of goo.
What is it?
It's the carnage of war.
Oh.
In that test tube that Willie's holding are millions of tiny single-celled plants called coccolithophores.
Coccolithophores.
Yeah, and there are lots of them in the sea.
There's probably about 100,000 of these coccolithophores in a teaspoon of seawater.
Tell me about the coccolith. What do they look like?
They're basically like tiny little translucent balls with that a slight tinge of green. But the key thing is they're
The outside of that
by
ball,
this
it has these white plates
tiny circular shields of chalk.
because the coccolithophores are fighting for their lives.
Fighting with whom? Each other?
Viruses. These viruses that are shaped like diamonds. So here's what happens. Imagine you're a coccolithophore,
Okay.
floating in the ocean, and along comes this diamond-shaped virus. And it jams its diamond tip into you.
In between these plates and actually get inside the cell.
The chinks in the armor.
That's right, it's like the chinks in the armor.
And the coccolithophore just engulfs it.
And the virus thinks, yes, I'm in here. And then it sort of makes straight to the nucleus.
And it's at that moment that the viral takeover begins. The virus kind of hijacks the cellular machinery that's usually used by the coccolithophore to make more coccolithophore stuff. And it starts making more viruses.
So inside the coccolithophore now, there are these little diamonds multiplying.
Yeah, they're filling up that space. And eventually, all these viruses head out of the coccolithophore.
In big belches or?
Like a steady stream of viruses.
Wow.
And each one of these viruses has the ability to go on and infect another coccolithophore cell.
In fact, those coccolithophores in that test tube that Willie showed me,
If I shake this stuck to the bottom a little bit, yeah.
those were in the process of dying.
You smell that? Yeah, so that, what you're smelling there, that's the infection. That's dimethyl sulfide you're smelling. So the infection is already occurring in this culture. So
And when the coccolithophore dies, those white shields kind of fall off the cell.
They sort of gradually sort of rain off over the course of the infection.
So as it's dying, after it's spewed out these viruses, it just sheds its plate and it kind of and then it dies.
Yeah.
And that creates this white chalkiness.
Yeah.
Well, so this means like the coccolithophores are not doing very well.
Well, they've got a couple of tricks up their little calcified sleeves. Sometimes when a virus enters, the coccolithophore will send out a chemical signal.
They're sort of shouting, "Hey, it's too late for me."
But save yourselves.
Oh.
And initially, this signal's pretty weak in the water. But as more and more coccolithophores are infected, the chorus of this chemical beacon grows louder and louder.
And so the other cells, they hear these messages.
And they change by messing with their DNA a bit. And they go from having those white shields on the outside to having these jaggedy scales.
Which we think might be impenetrable.
Scales instead of these plates.
That's right, yeah.
Shields.
Yeah, that's right.
Why aren't they just scaly all the time?
Because when they're scaly, they can't be the best coccolithophores they can be. They just don't grow as well.
So scaly is an adaptation against the viruses.
Exactly. And then finally, if all else fails,
Programmed cell death.
the coccolithophores just commit suicide.
It just shuts down and kills itself to prevent propagation of viruses.
But over time, the viruses have figured out how to
Prevent the cell from killing itself.
So it delays the death of the coccolithophore for as long as possible to maximize the number of viruses that can get out.
Wow, this is serious.
Yeah, it's like an arms race.
There's a constant battle to be fitter than you were several generations ago. And without
Here's
that
the crazy thing.
environmental pressure-
This battle is happening all through the surface of the ocean. There are legions of coccolithophores dying all the time. And the coccolithophores are shedding their white shields.
It's like taking millions of tiny little mirrors and putting them in the surface of the ocean.
So many that you can actually see this carnage from space.
You can see this from space?
Yeah.
You get the massive blooms that cover almost the whole of the North Atlantic. I mean, you get this sort of milky bloom that covers anything from, off the west coast of Scotland under southern Iceland, almost all the way to Newfoundland. In the southern hemisphere, you get this sort of massive milkiness that circumnavigates the globe.
These vast swirls of milky water curling around islands and continents.
And that's all carnage from this battle.
Billions and billions of soldiers that have fallen in the field.
Wow.
That we can view from space.
It probably is trillions if you're talking on that scale.
Yeah, I think,
What's after trillions?
Quadrillion?
You think it's we're in the quadrillions? Just say it, see how it feels.
There are quadrillions of soldiers dying.
How did that feel?
It felt good. If I were to be an astronaut, how often would I see these sorts of blooms?
All the time, somewhere on the planet.
Every day, every hour?
Every day, every hour, there's going to be a bloom going on somewhere. A good example is off the Norwegian fjords. They start in the fjords in late April into May time, and then they sort of creep out of the fjords like this huge living amoeba. Fishermen hate it because the fish can't see the lures, so they can't catch the fish anymore.
And as the shields rain off and fall down to the ocean floor, they build up and build up over time.
Millions of years of sedimentation of these sort of chalk particles.
That's actually what led to the creation of the Cliffs of Dover, the White Cliffs of Dover in England.
Shut up, really?
Yes.
This is sort of geology in action.
And not just that, when the coccolithophores get decimated by the virus, it kind of clears out the ocean for other phytoplankton to bloom. And then they get mowed down by their viruses. And then the coccolithophores might bloom again, and then they get wiped out. And this cycle...
all these battles, it's all responsible for about half the oxygen that we breathe.
Really? Half the oxygen we breathe?
Half the oxygen. Whoa. Because when the phytoplankton bloom, they take in carbon dioxide and they release a puff of oxygen. And then they're cut down by these viruses, but they grow back up again, and another breath is released. So the whole system is just kind of breathing.
People think of the lungs of the planet are the rainforests, and that's kind of half the picture. But every other breath we take comes from the phytoplankton in the ocean that are going through these battles on a daily basis.
So this is a battle that rages every single day somewhere in our oceans.
Yeah, we need the battle to live.
After the break, we go even deeper into the question of how much is nature worth anyway. Lulu, Radiolab. Today we're talking about the things that nature does that are mostly hidden to us. So we thought it would make sense to try to look as objectively as we can into what it's all even worth.
So we think of ecosystems as just kind of sitting there, but actually they're doing things. If they weren't doing them for us, we would have to pay to do them artificially. For example, cotton farms in South Texas. So, the farmers are doing their thing.
Like this guy.
James Parker.
Planting their cotton, they're collecting it.
I farmed about, usually 500 to 700 acres of cotton, so say 2,000 bales.
They're doing what farmers do.
I spend a lot of time on a tractor, and you have to check your water every morning, every evening.
Meanwhile, they have all this extra help in the air.
Yes.
They have bats.
How many bats are out there, you really don't know.
Flying all around. The bats eat the equivalent of 2/3 of their own weight in insects every night.
Wow.
They eat all night long, all kind of bugs.
A whole bunch of pests that would otherwise be eating the cotton.
Now, a few years ago,
A guy named John Westfall,
Did a calculation.
just to see how this arrangement was working out,
he came out to my farm and did a study. He had some college girls that worked for him, and those girls were out there all hours of the night listening to what the bats were saying. And
Each year, the farmers, collectively, they make about $4 or $5 million off of these farms.
the question was, how much of this was because of the bats? Because, bats are natural pesticides.
if the more they're eating, the less I got to spray.
And here's what the scientists figured out.
Out of $4 to $5 million, it was around $700,000 that you could ascribe to the bats.
It's just beautiful.
Wow. I mean, it does make me think that if you're those farmers, you should be compensating the bats somehow.
Yeah. It does give you a glimpse at the kind of scale of value, economic value, that nature has that we generally just totally ignore.
But we talked to a guy who didn't ignore it.
My name is Robert Costanza.
In fact, he took this way of thinking to the absolute limit.
Yes. So the question was, what's the value of all of these ecosystem services globally?
All the services on Earth.
It's bugs eating leaves,
Worms turning the soil,
beetles chewing tree stumps,
coral reefs protecting cities during storms.
everything.
We tried to synthesize all of the studies that had been done around the country and the world.
Like that bat study, except they didn't just look at cotton farms. They looked at
Tropical forests, rivers and lakes, coral reefs, coastal wetlands, inland wetlands, the ocean, woodlands, temperate forests.
It goes on and on.
Grasslands.
this must be some Excel spreadsheet.
It's kind of the Excel spreadsheet from hell.
It can get tricky.
So Costanza and his colleagues took all these different studies, summed them together, did a whole bunch of math, and came up with a number.
Which in today's dollars is $142.7 trillion per year of services. And that's more than all of the gross national products of the world.
Wow.
And that's how valuable the services of nature are.
Yeah, let me ask you. I get the way this would work with a bat. Like the bat's eating the bugs, but how do you do it with a field or something? Like, do you just walk through and you're like, yeah, that's $20 for services, that's 50. Like, how do you even figure out what the services are?
Well, they came up with a list. The list kind of depends on the ecosystem you're talking about, because different ecosystems provide different services. For example, a salt marsh.
And we are in the water now. Yes, we're in the water.
What is it? Wait, so a salt marsh, is it like the Florida wetlands but salty? I suddenly don't know what a salt marsh is.
Salt marshes are wetlands that are on the coast.
Got it.
Yep, we're standing in about a foot of water here. We're quickly approaching high tide.
We sent one of our producers, Simon Adler, to a nearby salt marsh.
Partially to haze him.
Your boots are much more waterproof. Yeah.
But really, to talk to this guy.
My name is Adam Welchel, and I'm the Director of Science for the Nature Conservancy here in Connecticut.
And Adam gave Simon a kind of inventory of
some of the services provided by coastal salt marshes. It's a stream of goods and services that are provided over time.
One of the things it does is it takes water that's coming in from inland and that's laden with all sorts of pollutants, all sorts of bad stuff.
The salt marsh will trap that water so that the pollutants settle, and then very often the marsh grass will suck up that water into the roots
and clean it up.
Yep.
So you could ask very simply,
how much would you have to spend to keep your water that clean?
1 second. Well, there is one other study I wanted.
Adam Welchel said that scientists in New England have already figured that out.
For flood control, water supply protection, pollution control, it's roughly about $31.22 per hectare per year.
Then you got to add the value of all the plants that feed the fish that end up on our dinner plates.
$338 annually per acre.
Then there are the bird watchers that buy lattes that support the local economy.
$490 per hectare.
And then there's habitat provisioning.
The list goes on and on and on and on.
You do get kind of obsessed with it. You start becoming an accountant and writing down numbers just furiously. It gets you to think about nature in a different way than you had before.
There's this galling element, though, or this aspect. Like when I first came across
At this point, our producer Tim Howard jumped into the interview, and you'll also hear our producer Soren Wheeler in just a second.
I do feel like in an example like the salt marsh, which cleans water, that's all reliant on people being there that need the water. So if you didn't have people there, does that salt marsh cease to have any value?
But Tim, haven't you ever had a conversation with somebody who just doesn't get? Like if you make the aesthetic argument, which is that nature should be preserved for its own sake, there's a whole category of humanity that just doesn't respond to that argument. This becomes a way to talk across the aisle.
But it does still feel like it demotes something of infinite value to something of a piddly value.
Well, it can't really be infinite value. I mean,
like a mother's love. You don't think your mother's love is priceless? I mean,
Okay. I totally accept that there is this sort of priceless aspect of nature. But if you are in the government in a very poor country, you have some tough choices to make. If somebody comes to you and says, okay, you've got these lovely mangroves. Now, it turns out that this sort of setting where the mangroves are is the perfect place for shrimp aquaculture.
Because shrimp farms need lots of seawater, so it makes sense to put them by the sea.
We're going to put in these farms. We're going to grow shrimp. You are going to get millions and millions of dollars in tax revenue. If you're thinking about the welfare of all the people in your country, many of whom are starving, that might be a really powerful argument. Now, into that kind of a discussion, you can bring in the fact that these mangroves are sitting there very quietly doing all sorts of incredibly valuable things. In fact, they've done these kind of calculations. And in some cases, the services that mangroves provide are 4 times more valuable than what you could get out with shrimp. So it's stupid. It's just stupid in a very basic sense to wantonly replace lots of mangroves with shrimp aquaculture.
Is that a hypothetical situation?
No.
That's a conversation you have.
That's what we're asked.
This is Glenn Marie Lang. She's an environmental economist for the World Bank, and she says very often she finds herself in exactly this kind of conversation.
Particularly, I work for the World Bank, so our primary clients are our governments.
Philippines, Vietnam.
And when you're talking to a minister of finance and saying, you know what, you really
I know jobs are jobs, but you need those marshes. They have value.
They'll say, well, yeah, that's true, but that that means I'm going to have to reduce the money that I put into the education budget. So you've got to really make a strong argument about the benefits. That's really where the rubber hits the road.
Well, I mean, that's it.
Here's the counter-argument. It comes from Doug McCauley, an ecologist at the University of California, Santa Barbara.
The real danger is that we actually succeed, that we convince people that nature is valuable because it makes money, and then we're really in trouble in the many instances where it doesn't make us money.
What do you do in a situation, he says, where, say, a bunch of rivers are running dry and they're, quote, depreciating in value?
You know, by the same logic that you train me to think with, we should go out and liquidate these natural assets. That makes me feel really uncomfortable.
He says it's just kind of a weird way to think about nature.
We had a proposal here in the state of California to make gay marriage legal. And economists had a look at this legislation and said, this is expected to generate $163 million annually for the state of California. Well, it's good to know that. I appreciate having that information in front of me. However, when I'm making a decision on this legislation, and I would say that when many legislators, voters, average citizens are considering the issues at hand, they're not thinking about whether they're going to make $160 million for the state. They're thinking about a different set of values.
On the other hand, I want to say, and this is based on my experience working in developing countries, that when you don't put a value on these services, basically they don't get counted.
They get implicitly assigned a value of 0, according to Glenn Marie Lang. And as we were debating this and going back and forth, we bumped into a story about what happens when all of these value of nature ideas are let loose into a world of fruits and trees and human uncertainty.
The parable of the bees.
We heard this first from writer J.B. McKinnon, who says the story begins
in Mao County in central China, rural area, fairly remote.
Lush green mountains filled with apple orchards.
And apple orcharding was the main business.
And according to JB, in the 1990s,
the wild bees of Mao County slowly started to disappear. And there's a few different reasons given for that. It could have been the destruction of the habitat that the bees nested in, the heavy honey harvesting that wasn't leaving enough food for the bees.
But the prevailing theory is actually an economic one, because in the 1990s, as China was shifting to a market-based economy, apple producers were under pressure to produce more apples. So they started spraying pesticide.
Probably it was a constellation of all of those things and a few others. End result is the bees stopped buzzing in Mao County.
Which, if you are an apple farmer, that's a disaster.
As bees travel from flower to flower in search of nectar, they're dusted with pollen, which is the means by which flowers engage in sexual intercourse. So if you don't have the bees making the birds and the bees on the blossoms, then you don't get fertile flowers to turn into fruit.
And obviously, if you're a fruit farmer and you have no fruit to sell, you have no income.
So what do you do?
If you're an apple farmer and you don't have bees, then you need to find some other way to pollinate the flowers. And I guess they concluded, well, we'll have to do that ourselves by hand.
In Mandarin Chinese, we say zhen gong shou fan. So basically, that means a manual pollination.
This is Harold Thibault.
I'm a correspondent in China for the French newspaper Le Monde.
A couple of years ago, he heard about the apple farmers in Mao County, so he flies to Chengdu, and he and a friend hop in a car. And
we drive for like 5 or 6 hours until we reach this village, Nanshin.
Tiny little village.
It's like only a few houses. And then we took a small road between the fields. And we actually saw that there were lots of farmers in the trees, like on the apple trees.
Straddling up on these often thin and spindly branches, men and women that I've seen in photos in any case.
Harold and his friend took pictures, and if you look at those pictures, you'll see the farmers holding a little brush.
This little pollen brush that they'd constructed using things like chopsticks and chicken feathers and cigarette filters.
And they'd have a little bottle filled with pollen, and then what they do, they dip the brush into the bottle and they paint a flower blossom with the pollen. They dip their brush back into the pollen and they paint the next flower blossom again, and then they dip the brush back in again and they paint again and they dip again and they paint again.
To make sure that all of the blossoms that they could possibly fertilize would be fertilized so that they would go on to produce fruit.
We're talking hundreds and hundreds of flowers per tree.
It was very strange to see humans doing the job of the bees.
God, what a pain in the ass that sounds like.
Yeah, the image of these
Chinese orchardists standing up in these spindly trees traveled around the world through environmental circles. And the message that it seemed to send was that, this is what happens if you lose biodiversity. You end up standing in the trees doing the job that the bees used to do on the wing.
For free.
For free.
Those people are just like human bees.
But then this guy enters the story. This is Yin Sun Chen.
Yeah, human bees.
4 years ago, he traveled to Mao County to do a sort of economic analysis of just how much the loss of the bees was hurting the farmers of Mao County. But what he discovered, weirdly, was that the trees were producing more apples than ever.
More production. This can be confirmed. There are more production for hand pollination apple tree than bee pollination apple tree. Humans are more efficient.
Really?
You mean the people were doing it better than the bees had been doing it?
Yes.
A lot better.
Fruit production went up 30%.
That's what the farmers told Yin Sun Chen, which is kind of
amazing. The only word I remember, amazing. Because I think hand pollination can pollinate more thoroughly. They can pollinate every flower.
And bees don't pollinate every flower?
Bees are a little bit, they're a little bit uneven when it comes to pollinating.
You're so polite.
They don't like it if it's cold. They don't like it if it's damp. They don't like it if it's windy.
In all those cases, bees often decide to stay indoors and just take the day off.
But you send people out there and tell them to pollinate every damn blossom, and they're going to do it. And there was the additional benefit of the people that you paid. They'd go to the bar, they'd buy groceries, they'd spend those earnings in their local communities in a way that obviously bees never did.
So here you had this whole story that was supposed to be about how important the bees are, this whole parable of biodiversity.
And it turns out maybe the lesson's just the opposite, that actually we don't need bees, and maybe we never did.
If we only measure things economically, then we might conclude that some species or some ecological processes just aren't necessary in certain places, or that we might even do better to take care of those processes ourselves.
Right. So let me find my notes about the wages exactly.
But there's one more chapter to the story. Harold Thibault told us that when he visited Nanchen,
I talked with one farmer. His name is Zheng Zhegao. He's 38. And he said, in his opinion, the hand pollination might disappear in a few years.
Apparently, as China's economy has continued to grow, workers have started demanding better pay.
The wages are getting so high for the workers that the farmers have to employ to help them. Basically, it's not efficient economically to do the hand pollination anymore. That's what a lot of farmers say.
Now they're likely thinking, damn, we need those bees back.
Right, yeah.
Problem is,
there are no bees in those villages anymore.
One farmer told Harold beekeepers in other parts of China aren't going to bring their bees to this area because they worry about the pesticides that the farmers have used. But as for when wild bees might come back?
Well, for this, we have no idea. It's very hard to make a prediction. If you ask the farmers, they're like, 我不知道, I don't know.
Here's where that story leaves me. It leaves me thinking that economics is just not a good way to go. Putting a value, even a precise and thoughtful value on a bee or on a pound of pesticide, you do it and you think you're smart, but then the value changes. The bees go from being worth a lot to being worth nothing to being worth everything, all within a few years. This is what markets do. They swing back, forth, and we pretend that we can predict, but we never can. So you can't put a value on because you're always going to be wrong. That's why economics is a dumb...
Well, no. I want to argue the other side for a second. Nowhere in this story did someone walk into the middle of the proceedings and say, you know what, the bees do have value. Here's the number. In fact, you know what, Carl, when we were talking to him, told us...
there have been estimates that the value of the pollination that comes from wild bees is $190 billion.
So that's globally, right? But still, there was nobody in the room giving that kind of number. So the bees were inherently valued at zero.
But remember, bees are valued at zero only until humans get valued more. Then bees go down, bees go up. You have to have a lot of numbers in your head.
But here's what I like about this idea is that when you put a number on a bee or a bat or a marsh, it's like an attempt to force a kind of long-term thinking. You can't just say, don't do that. I mean, that's the thing that like conservationists say, don't. But if you say, don't do that because here's the value.
Here's the loss, you're going to say.
Yeah, here's the loss. Well, then that actually gives the whole precautionary don't thing some teeth.
Except for this, that if you go businessy on nature and you're wrong,
there are irreversibilities.
That's how environmental economist Glenn Marie Lang puts it.
This is one of the differences between nature, ecosystems, and what we produce. If you smash your car, hey, someone can build a new one. If you lose the bees, many instances you cannot bring them back.
So the question we got to is there another way to think about the value of nature? I mean, a way that's not economic and therefore short-sighted and all about us, but also not simply about the aesthetics and the beauty, because that can be sort of limiting too. Is there another way?
The best I was able to do thinking about this,
writer J.B. McKinnon again,
was when it struck me that in a way, all of this diversity that's out there, all this biological diversity, all these wonderful and amazing and alien things that other species can do is like an extension of our own brains. There's so much imagination out there that we simply could not come up with on our own, that we can think of it as a pool of imagination and creativity from which we as humans are able to draw. And that when we draw down on that pool of creativity and imagination, we deeply impoverish ourselves. In a sense, we are doing harm to our own ability to think and to dream.
J.B. McKinnon's book is called The Once and Future World. He's written many, but this one is my fave.
Deep thanks to Carl Zimmer, who's reporting in the New York Times on this topic, is really what got us launched into this whole thing.
And what got us through this whole thing is Simon Adler, whose production assistance was invaluable. That was him
freezing his ass off in the marsh.
I talked so long in that interview that he nearly died. His toes fell off, I think. Anyway, thank you, Simon.
Thank you, Simon. And thank you guys for listening. I'm Jad Abumrad.
I'm Robert Krulwich.
We'll see you next time.
Hi, I'm Paolo Marabiggs, and I'm calling from Nuuli, American Samoa, and here are the staff credits. Radiolab was created by Jad Abumrad and is edited by Soren Wheeler. Lulu Miller and Latif Nasser are our co-hosts. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, Becca Bressler, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Namasamandam, Matt Keelty, Anna McEwen, Alex Neeson, Sarah Kari, Sarah Sandbach, Anissa Vitsa, Ariane Wack, Pat Walters, and Molly Webster. Our fact-checkers are Diane Kelly, Emily Krieger, and Natalie Middleton. Papatai Telelava Malo.
Hey, I'm Steph. I'm from Melbourne, Australia. Leadership support for Radiolab's science programming is provided by the Gordon and Betty Moore Foundation, Science Sandbox, a Simons Foundation initiative, and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.